Hello, everybody, and welcome to week 5 in algebra. Please make sure you've got your math notebook out and you're ready to take good notes. And we are going to start with using our notebooks for the warm-up problem. We've got 2 of them below. And if you look, there is a parabola graph. And remember, parabola is the graph that we get when we graph a quadratic equation. And quadratic equations is what we've been talking about so far as we've started Unit 6. So we are in a brand new unit, Unit 6. So just a reminder that I am no longer accepting redos for Unit 5 since we've moved on to Unit 6. So grab your math notebook and you're going to answer 2 warm-up questions based on this parabola that is graphed over here to the right. So I do want you to click pause and try this in your math notebook. Answer these 2 questions in your math notebook on your own first. So the first question is find the zeros of the parabola to the right. So if you need to review what that means, look back to your notes. And then the second one, whoops, I should be adding, hold on a sec here. I had to add the squared term to make this equation a quadratic function. But here it says the second question actually is not dealing with this graph of the parabola on the right. The second question is you need to solve by factoring this quadratic function, x squared plus 5x plus 6 equals 0. So for the first question, you will use the graph on the right. For the second question, you're just going to use that equation and solve it by factoring. So go ahead and click pause. Try these 2 on your own in your math notebook, and then when you're ready to check your work with mine, go ahead and click play. The squared term on there. All right, so when I say find the zeros of the parabola on the right, what does that mean when I say find the zeros? So remember, the zeros are where we intersect. We're looking to see where the parabola intersects the x-axis. So we look at our parabola to find the zeros, and we find where it intersects the x-axis. And in this case, it intersects the x-axis, our horizontal axis, twice. So we have 2 zeros. So we actually have 2 zeros that we need to find. And those zeros are going to occur when, let's find those 2 values. When x equals 1, right? Here's that point right there, x equals 1. And where does the other x, or the other 0 occur? When x equals what? When x equals 3. So we've got 2 zeros, when x equals 1 and when x equals 3. And again, the zeros are where your parabola, whether it opens up or opens down, where it intersects the x-axis. All right, the second problem we need to solve by factoring. So in order to factor, we know we're going to have an x and a plus or minus a number times x plus or minus another number. So how do we figure out what goes after each x? Well, we look at for our constant term, and in this case the constant term is 6, it's the only whole number, and I look to see what are factors of 6 that add up to our middle term, which is 5 in this case. So what are some factors of 6? And when I say factors, 2 numbers that multiply times each other to give us 6, but they also have to add up to equal 5. So I'm thinking 6 and 1 wouldn't work, because if we had 6 and 1, they would equal 7. What about 2 times 3? 2 times 3 equals 6, and when we add 2 plus 3, we get 5. So that means both those are positive, so we're going to have x plus 2 and x plus 3. That is going to be our factored form. Now, we need to solve. And remember, this equation was set equal to 0. So then, we know that when either one of these sets of parentheses is equal to 0, well, then when we multiply it times the other set of parentheses, it has to equal 0, because anything times 0 is 0. So what I'm going to do is I'm going to set each of these factors equal to 0, and then I'm going to solve. So I'm going to do it for both these factors, set them to 0, and solve for x. Subtract 2 from each side to solve for x plus 2 equals 0, and I get x equals -2. That's one of my possible answers. Then I'm going to solve this other equation over here where I have x plus 3 equals 0. I'm going to solve it by subtracting 3 from each side, and I get x equals -3. So when I solve by factoring, I get that x can equal -2 or x can equal -3. Those are my two answers, and I did it by factoring. So that gets us warmed up and thinking about what we've been learning about so far in Unit 6, which is all about quadratic functions. And remember, a quadratic function is it's a equation with the highest degree of 2. So it's going to be something that has a squared term in it, no higher or no lower. So this week we're going to continue exploring quadratic functions, and we are going to look at some of the characteristics that we learned about quadratic functions. That's going to help us this week when we go to graph quadratic functions. And then we're going to finish out the week with transforming quadratic functions. And remember, transforming just means to take a graph of something and move it around. Either move it up, down, left, right, or make it shrink it, make it wider, make it narrower. So we're gonna finish out the week with transforming quadratic functions. So here we go. Let's jump in. So let's review some parts of parabolas. Remember, parabolas is just a fancy way of saying the graph of a quadratic function. So make sure we understand our vocab here, and you see parabolas, you're going to see that word a lot, and it's just the graph of a quadratic function. So when we look at graphs of parabolas, which is quadratic functions, remember they can either open down, as in this case, or they can open up. So just to review that you can either have a graph that opens up, or as we say, opens down. And that is based on, remember, let's write down over our general equation for a quadratic function is going to look like this, where a and b and c would actually be numbers. So if we have y equals a times x squared plus bx plus c, we can tell if our parabolas open up or down based on that a value. So if a is greater than 1, it's going to open up, and if a is less than 1, it's going to open down. Let me change that. I meant to say 0 here. I don't know why I was saying 1. I meant to say 0. So if it's greater than 0, if it's a positive number, it's going to open up, and if it's less than 0, it's going to open down. If it's a negative number, it's going to open down. Catch that really quick. I didn't mean to say 1. All right, so what is the vertex? Where is the vertex located in our parabola? If you said right here at the top, right there, you are correct. So the vertex in this case would be the most maximum value, because the vertex will tell us if it's the most minimum or maximum value. If we were opening up, it would be the most minimum value. So the vertex right there, that is our vertex. And what about the axis of symmetry? Well, the axis of symmetry intersects our vertex. So the axis of symmetry intersects our vertex, and it just really is a mirrored line that if we were to fold the parabola, it would fold onto itself. So the axis of symmetry is right here, axis of symmetry. What else do we have? Blue there, we did that. The y-intercept, and it's just like what it says. The y-intercept is going to be where our parabola crosses the y-axis. So in this case, it would be right here. This would be our y-intercept. And then x-intercepts, which are like the zeros that we just used in our, where we looked at our warm-up question. It's where our parabola crosses the x-axis. So we have, in this case, two x-intercepts. And it's our zeros. Whoops, I'm running out of room here. Getting a little bit messy. I apologize about that. So that's a review of some of our main characteristics or main features of parabolas. Is that we always have a vertex. We always will have some x-intercepts, and then a y-intercept, and an axis of symmetry. And we're going to use these features to help us graph quadratic functions. And we're going to do that, we're going to look at how to do that on the next slide. So I'm going to go on to the next slide, so if you need more time here, go ahead and click pause, otherwise I'm moving on. All right, so we are going to use those key features that we just reviewed on the previous slide to help us plot some of our key features and then graph a quadratic function. So again, remember, a quadratic function, we write it in the form of ax squared plus bx plus c, and the a, the b, and the c will represent numbers. So if we were to ask to graph this generic ax squared plus bx plus c, first of all, we can tell right away if our graph opens up or down. I reviewed that on the previous slide when I made that error first saying a is greater than or equal to 1 when I meant to say 0. So if we have a negative number, our graph opens down. If we have a positive number, the graph opens up. The y-intercept, if we are asked to identify the y-intercept, it's pretty easy. The y-intercept is just going to be the c value in our quadratic function equation. Remember, our c value is just that whole number, the constant number. So if we look at our equation and find that constant number, that's going to be where our y-intercept is going to be located. It's going to be at the, it'll have the coordinate 0 and then whatever the c value is. So we would go 0, c. That is going to be our y-intercept, the coordinate. The x-coordinate of the vertex, so if we are asked to find the vertex, we start with finding the x-coordinate of our vertex. So if we're asked to find the vertex, this point right here, remember it's in the form of xy, our coordinate. So in order to find the x-coordinate, we're going to use this equation right here, negative b over 2a. So the b term is going to be that coefficient that's being multiplied times the x right there. And then we're going to take it and divide it over 2 times a. And a is the term being the coefficient being multiplied by x squared. And we're going to practice this on the next slide. And then once we have the x coordinate, we'll plug that value of x into our equation that we were asked to solve to find the corresponding y value. We're going to do that on the next slide. We'll get practice. And then the axis of symmetry is simply, it's a vertical line. And remember, a vertical line, the equation is always x equals a number. Well, to find that number that x is equal to, we're going to use that same equation that we did to find the x coordinate of our vertex. Because look, the vertex, that x coordinate is going to be what the equation is for the axis of symmetry. Again, we'll do negative b over 2a. So are you ready to try this? It always makes a lot more sense once we actually jump in and look at an example and get our hands a little bit messy. And let's do that on the next slide here. We are going to graph this quadratic function that I just added here up in orange. So we're going to graph this quadratic function, y equals x squared minus 2x minus 3. So first of all, do we know if this graph opens up or down? Just to have an idea in our mind if it opens up or down. Well, in order to figure that out, we're going to look at the a term. And in this case, it's x squared. So we know our a is just positive 1. We don't need to put a 1 in there, but the a is positive 1. That should have a square there. So we know that our graph is going to open up. So first of all, we know our graph is going to open up. That just gives us an idea in our head of what it's going to look like and make sure that we're going in the right direction. All right, so how do we graph a parabola? So we're going to use our quadratic function right here, and we're going to start with finding the axis of the axis of symmetry. We're going to find the equation for the axis of symmetry, that dotted line that goes through our parabola and cuts it into two mirrored parts. Remember, it goes right through the vertex. So in order to do that, we're going to use the equation x equals negative b over 2a. And let's go ahead and look at our equation. So what is our b term? So b is right here. It's the number being multiplied by our x. So in this case, the number being multiplied by our x is a negative 2. And it's important that we note the sign that's in front of the 2. That sign belongs to the 2. It's a negative 2. So we're going to take, it says negative b, so I know my negative b is a negative 2. So notice there's two negatives in there. That's because we're taking negative times b. Here's my negative, and we're multiplying it times b, which happens to be a negative 2. And then we're going to divide it by 2 times my a term. Remember, the a is being this is a coefficient of the x squared term. It's a 1. It's a 1. We don't have a number here, but we don't need to put a 1 in there. It is a 1. All right, so then we do the math. A negative times a negative, we really have a positive 2 on our numerator. And then 2 times 1, we've got a 2 on our denominator. So 2 divided by 2 is 1. So the axis of symmetry is going to be that vertical line at x equals 1. All right, so moving on. Now we want to find the vertex. So remember, we're going to have a coordinate. We're going to have a coordinate for the vertex. So to find the x coordinate of the vertex, we use that same equation. So to find the x coordinate, remember, we're going to have a coordinate. We're going to have an x, y value. So to find that x value, we're going to use that same equation. We already did that, right? So we already know that the x coordinate of our vertex is going to be equal to 1. We just did it for the axis of symmetry. Remember, the axis of symmetry actually intersects our vertex. So we already know the x coordinate of our vertex. It's going to be x equals 1. So now we need to find, well, what is the y coordinate? So let's use our equation up here. And anytime we see x, we're going to plug in 1. We'll do the math to find out what our corresponding y value is. So I'm going to use orange here, different color. So remember, y equals x squared minus 2x minus 3. So we want to find our y coordinate now. We know our x coordinate is 1, but we want to find our y coordinate. So if x equals 1 squared minus 2 times 1, minus 3. And we're just going to do the math to find our y coordinate. So I know 1 squared is 1. I know negative 2 times 1 is negative 2. And then I'm going to subtract 3. So do the math. 1 minus 2 is negative 1. And then take away 3 more, and we get negative 4. So I just did 1 minus 2 minus 3. And that gave me negative 4. So I know the y coordinate of my vertex will be negative 4. So there's my coordinate right there. 1, negative 4. I'm going to write it over here. All right, next step, step 3. Once we get all of our, we do all of our steps, then we're going to graph it. So the next step is to find the y-intercept. So where our parabola crosses the y-axis. And remember, it's always going to be in that format of 0, c. So what is this c value? That's our constant. It's our constant, and it's a negative 3. So the y-intercept is going to occur at 0, negative 3. 0, negative 3. That's a negative 3. All right. So let's go ahead and plot everything we have so far. So I'm going to start with I'm going to plot the vertex. So the vertex is at 1, negative 4. So go to the right and then down 1, 2, 3, 4. So there's my vertex. I know my axis of symmetry is going to go right through that vertex with the equation of x equals 1. I know Now that we've got our vertex plotted, let's go ahead and plot the y-intercept. I'm going to do that in blue since let's keep all of our, yeah, I'll do it in blue. So the y-intercept is going to be where our parabola crosses the y-axis, and that is at 0, -3. So not going left or right for my origin, and then I go down 1, 2, 3. So there's my y-intercept. And now I don't have enough information to fully graph, right? I've got a good template going, but in order to graph, I need some more points. So that's where step 4 comes in. So I'm going to find 2 more points on my graph that fall on the same side of the axis of symmetry of the point containing the y-intercept. So on the left, to the left of my axis of symmetry, I want to find 2 more points. So how about when x equals 1, what would be the y-coordinate? What would be that point there? When x equals, actually I want to say -1 because I want to be to the left of my axis of symmetry. So when x equals -1, what is the corresponding y value? So in order to figure that out, I'm going to plug x equals -1 into the equation that we're graphing. And remember, the equation that we're graphing is y equals x squared minus 2x minus 3. And so what I'm going to do, whenever I see x, I'm going to plug in a -1. So -1 squared minus 2 times x, which is -1, and minus 1. Then I do the math. -2 squared is -1 times -1, which is a +1. -2 times a -1 is a +2. And then I'm going to subtract 3. So what do I get? 1 plus 2 is 3. 3 minus 3 is 0. So that point that I can plot is -1, 0. That's another point. So -1, 0. Then I need 1 more point. How about when x equals -1, -2, -3? We can choose any x value. So I'm just going to do -3. What is my corresponding y value? Again, I'm going to plug it into the equation that we're using to graph. So I would have y equals -3 squared minus 2 times x, which I said is -3, and then minus 3. Running out of space. Okay, do the math. -3 squared is the same as -3 times -3, which is 9. -3 times -2 becomes a +6, and then I'm going to subtract out the 3. 9 plus 6 is 15. 15 minus 3 is 12. So at -3, we would have the corresponding y value would be +12. That's going to be my second point. So I have 2 points. So at 1, 2, -3, and then up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need to go up 2 more spaces. I got outside of my realm on my coordinate plane. Then I want to reflect all these points across my my axis of symmetry. I'm going to reflect these. This point is 2 units away on the left, so I'm going to go 2 units away on the right, and then same with up here. This one is, what do we do? 1, 2, 3. So it's going to be 3 away up here. Once we have all those points, we can draw in to our best ability the shape of our graph now, going through the points, and it should make a nice U shape. It's a little harder for me doing this on the computer, so bear with me. So there is my graph. I have my axis of symmetry, my vertex, my y-intercept, and then I plotted 2 more points and reflected those over the axis of symmetry, and I get my nice opening up parabola. So I'm going to go on the next slide. So if you need more time, go ahead, click pause. You'll get lots of practice on graphing parabolas using those key features, finding the axis of symmetry, finding the coordinates of the vertex, finding the y-intercept, and then finding 2 more points on the same side of the axis as our y-intercept. So we're going to wrap up this week 5 recording. We did not go over transforming Parabolas. So you will learn all about the transforming of parabolas in the lessons this week. I didn't want this recording to get too long. We did focus on graphing quadratic functions in this recording. And one of the things that you learned is how to find the axis of symmetry equation by looking at the quadratic function, the equation that was given to you. So I want you to look at this equation, y equals 3x squared plus 2x plus 6, and I want you to tell me what is the equation for the axis of symmetry of this quadratic function. And that is it. So you will get your 10 points for watching this recording by answering this question correctly. And let me know if you have any questions from any of the lessons this week, and have a fantastic rest of the day and week.